Bill Nye the Science Guy. Bill Nye the Science Guy.
Science rules.
Bill Nye the Science Guy.
Inertia is a property of matter. T minus 7 seconds.
Bill Nye the Science Guy.
Yes! Yes! Oh no! What's the emergency?
How you add a group to a benzene?
That's easy. Have you guys tried EAS?
Emergency alert system?
No, not emergency alert system. Electrophilic aromatic substitution. So this is the general mechanism for adding an electrophile to a benzene. Firstly, the double bond attacks the electrophile, which adds the electrophile to the benzene, creating a carbocation intermediate. However, the aromaticity of the benzene has been destroyed. So to restore that aromaticity, this hydrogen needs to be deprotonated to reform the double bond. This gives you the desired product.
But what if there's something already on the benzene?
That's a great question. When you're adding a group to a benzene, there's 5 possible places that they can go.
Stop overcomplicating things. It can either go ortho, meta, or para.
Jackson, that includes every single position.
Well, Sarah, if you would let me finish, it depends what the directing group is.
Go back to directing traffic. This is my show.
Should I go meta or para?
Go meta, it's on the lot down to the right.
Right, thank you.
So there's 2 directing groups, electron donating and electron withdrawing groups. To help me explain electron donating groups today, my friend and colleague, Sir Dr. Mr. Electron Donating Group, has been kind enough to join me on the show.
Well, hello, mate.
Nice to see you again.
Oh, yes, thank you for having me on your show. So I'm just going to start off by drawing a couple of resonance structures here. So basically, what we have here is 2 ways that the electrophile can go onto the benzene ring. Over here is commented as the meta position. And on the meta position, you can see that there's only 3 resonance structures. Over here, this is the para position. The para position is favored in this case because there's 4 resonance structures over 3. But watch yourself, because that's not necessarily why. 4 is not always better than 3, like in golf. But this works, and 4 is better than 3 because we have this lone pair. Not this kind of lone pair, Bill, you suck! The oxygen atom, not from a pair, contributes to the resonance structures by creating delocalization of charge that's greater than this meta position. Over here, the oxygen's not capable of donating electrons. But for here, it is.
Awesome. Thank you for explaining that, Sir Dr. Mr. Electron Donating Group.
Yep, no problem.
So that leaves us with how do we put things in the meta position. To help me explain that, I brought Sir Dr. Mr. Electron Withdrawing Group onto the show. Nice to have you on the show.
Thank you for having me.
So when we have an electron withdrawing group here, once again we have resonance forms with it going either meta or para. So when this goes meta, we have 3 resonance forms, and when it goes para, we're going to have 4 resonance forms. Now, you might think that 4 resonance forms is better than 3 resonance forms. But when the electrophile is in the para position, we have this unfilled octet, which is destabilizing. So because of that effect, the 4 resonance forms is worse than the 3 resonance forms, so the meta position is preferred for an electron withdrawing group.
Thank you for joining me on the show today and explaining electron withdrawing groups to us.
Of course.
Oh no, another one.